In the last session, we built an inference pipeline because we had a big problem with that endpoint. Before we created that inference pipeline, our endpoint was not capable of processing raw data. We had to provide the data, the input to that endpoint, we had to transform it first. By creating an inference pipeline, we were able to put together three components within that inference pipeline. One pre-processing component, then that pre-processing component, the output of it, went as the input to the TensorFlow model that we built before. And the output of the TensorFlow model, we post-process to provide like a human readable answer. There is a different way to build or accomplish that same goal without having to create an inference pipeline. Obviously, an inference pipeline is gonna be a little bit more complex to manage because you have three separate models. We had to do a lot of work to get those three models working together in the last session. So let's try to accomplish the same thing using a similar technique than what we used to create those pre-processing and post-processing components in the first place. Remember that we provided a custom inference script that SageMaker used to run inference. Basically, what we did was we used a normal sklearn model with a custom inference script, with an input function, an output function, a predict function, and a model function. And that was our way to instruct SageMaker about how to process data, how to do, or how that inference process should work. We are going to do the same thing here. Instead of creating an inference pipeline, we are just gonna create a custom inference script for the regular model that we already built. So we're gonna deploy our TensorFlow model, but instead of letting SageMaker handle and do whatever it needs to do with that TensorFlow model, we are going to tell SageMaker how to deal with an input request. And within that script, we are going to run the pre-processing step. We are gonna let the model handle a prediction, and then we are going to post-process that prediction. So this is what that code will look like. We're gonna start by creating that inference script. And there are two ways that we can do that for a TensorFlow model. There is a link here that is going to show you how to use that, how to create that custom inference script. And on this link, you can see that the first way for our TensorFlow model is providing a file, an inference.py file, where you're gonna implement an input handler and an output handler. So this is one example that you can follow. This is the input handler and an output handler. And through this example, you basically provide what the input would look like, how you're gonna manage that input. SageMaker will take care of calling the model, and then it will give you back control so you can handle the output. And there is a second way where you get complete control, where you provide a handler. So you provide a handler function. That is what I'm going to be doing in our code. And within that handler function, you have to take care of everything, right? So SageMaker, when it gets a request, when your input gets a request, SageMaker is not gonna do anything with it. SageMaker is gonna tell you, hey, handle this request. And you have to take care of that internally. This is the one that I'm going to show you. It's not the simplest one. It will be simpler to just provide an input and an output handler, but it's the one that's gonna give you the most flexibility. And that is what I wanted to show you here. So we are going to be creating that inference script now with a handler function. This is gonna be our inference script. I'm saving this inference script in the same folder that we created in the previous session, the same pipeline folder. So here is the inference script, and you'll see what that looks like. It has a handler function. Remember, an inference script has to have a handler function because SageMaker will be looking for that function. SageMaker will call that function when it gets a request. SageMaker is gonna send us two pieces of information. It's gonna send us the data that contains the input request, and it's gonna give you a context variable. And that context variable is important because through that context variable, we will get access to the model. Remember, this is running within an endpoint. So there is a model hosted somewhere, and we can get access to that model through that context variable. This third variable, I created just to test this locally. I obviously have to give it like a default value because SageMaker will never pass me a value there because SageMaker is not gonna use that directory. I created it just to test this inference script locally, and I'm just providing a default value there. You'll see how I'll use that in a second. Within this handler, I'm gonna be doing three things. I'm gonna be calling a function that's called process input, and that function I'm gonna pass the data, that I received, the context and the directory. Then I'm going to call predict, which is another function that I implemented here, passing the processed input that I created here. And finally, I'm going to call process output. So it's just basically doing the, hey, pre-process the input first, then make a prediction, then process the output, and that will be the output that you're going to send back to the client. So let's first look into the process input function. Let's see what I'm doing here in the process input. Okay, so let's focus on this function here. I'm going to be passing the data, I'm going to be passing the context, and I'm going to be passing the directory here. Here, I'm first going to ask if context is none. Here's the thing. If I'm running this locally, I will not be receiving a context because I'm just going to be passing null here or none. If this was running in a real endpoint, then context is going to have a value and I'm going to have to deal with that. But if I'm running this locally, I'm going to be assigning the data variable to the endpoint input variable. So I can later on work with that endpoint input variable. If context has value, that means this is running in an endpoint, I'm going to check the content type. And I'm going to do something different depending on the content type. So if the content type is JSON or octet stream, then I'm going to decode that data. I'm going to assume, okay, so this is a JSON object. What I'm receiving here as the input, I'm just going to decode it and I'm going to save it here in this variable. If it's not JSON, I'm just going to raise an exception. So for now, this implementation of my inference process does not support text CSV input. I have an assignment for you to add support for text CSV, but this one here does not have support for text CSV. I only support JSON as an input. So now that I have my endpoint input variable, I need to process it. This is the way I'm going to process it. I'm going to convert that into a JSON object. So I'm going to basically take this JSON string, convert it into a JSON object. I'm going to load that using pandas into a data frame. And then I'm going to load the library features.jotlib. Remember, it's the same thing that we did during the inference pipeline. This inference script has to have access to the features.jotlib pipeline and the target.jotlib scikit-learn pipeline. Those two files have to come together in the model.targc package. And we're going to see how we supply that later, but I'm assuming that here I'm going to have access to those. So I'm loading that features pipeline in memory, which is the scikit-learn transformation pipeline, and I'm calling transform. We saw the same thing in our inference pipeline before. So basically this function here, by the way, that's the end of it. I just returned that as a list or the transform data as a list. This process input function, what it does is receives JSON data, loads it into a pandas data frame, transforms it using the scikit-learn transformation pipeline that we created in the first step of the pipeline, and it's done with it. Okay, it's going to return that transformed information back. Getting back to the handler, after I process the input data, I'm going to call the predict function with that transformed data. I'm passing the context and I'm passing the directory as well. So let's see that predict function. Let's see what happens. Okay, so there are two ways, or there are two things that we can do here. There is the mode where I'm running inside the endpoint. This is running in SageMaker. And there is the second mode where I'm just running this locally just to test this script. So I have two different scenarios here. When I'm running in SageMaker, that's the important one. That's the one that we need to implement so this works in a real endpoint. When I'm running in SageMaker, I'm going to be using the context variable to post a request to the model. So what happens is that SageMaker within the container is going to be running TensorFlow serving. TensorFlow serving is going to be exposing our model as a RESTful API. In the context or through the context variable, I will get access to that RESTful API. So I can post a request to that RESTful API and get an answer from my model. Obviously, that is not the way it's going to run here locally when I load this script in memory just to run some unit tests. So I need to simulate the predictions. How do I do that? It's very simple. If the context is known, I'm going to be importing Keras. I'm going to only import Keras here within this condition, so I don't want to load Keras when this endpoint is running. I'm just going to be importing it here if the context is known. Remember, this is just for testing purposes. I'm going to be loading the model in memory. I'm going to be running a prediction using the instances that I'm passing to this predict function, and I'm going to be returning the result in the same format that these predictions would be created if I would be calling the Keras model in production. This is what I'm going to do just for testing purposes. Now, if this is running in SageMaker, I need to use the context to access the real model. This is how you do that. First, I'm going to be creating the input. Remember, the TensorFlow model expects a specific input format. So I'm going to be creating that, basically an instances entry in a JSON with all of the samples that we want to run predictions for. And look at this. I'm sending a post request to the REST URI that is a property of context. TensorFlow serving is exposing that endpoint internally for the container, for the endpoint container. I'm going to be sending a request to that endpoint container. And this is the URI of that. And I'm going to be passing that data. This is going to give us back a response, just an API call. It's going to be giving us back a response. I'm going to be checking or making sure that that was a 200 status code. And if it is, I'm just going to be loading the response, loading it as a JSON, because we know that the TensorFlow model is going to be sending us a JSON back. That's it. This is what this predict function does. As a summary, if we're running this locally, internally, just for testing purposes, I'm just going to be loading the model with Keras and processing the prediction. If we are running in SageMaker in the cloud, I don't need to load the model in Keras because I know SageMaker already did that. There is a TensorFlow serving running in that container, exposing an API that I can just use to run a prediction. Okay, cool. So that is the predict function. I'm returning the output back. And now the next step in that handler function is just processing that output. So I'm going to be passing the output that I got from the predict, the context, and the directory. So let's see what I do in that output. So this is what's going to happen. Processing prediction received from the model. If output, I'm printing here. That was just me debugging. I'm just going to get rid of it. If the output is not none, I'm going to be computing the argmax. So I want to get the actual predictions. What are the species, the index of the species? I'm going to be grabbing the confidence. I'm going to be loading the target pipeline. We did this when we created that inference pipeline. I'm just loading it here now. And I'm just grabbing, remember that we grabbed the array of classes, Adelie, Gentoo, Chinstrap. I'm just doing it here so I can actually translate the prediction index into the name of the class, which was our purpose from the beginning. These are the classes, and here is the result that I'm going to be sending back to the client. Prediction is going to be, I'm going to grab classes and I'm going to put the prediction inside. And the confidence is going to be the confidence that I computed here. That's it. It's that simple. This is going to be my result. And if output is none, that means there was an error before. I'm just going to be returning prediction in none. Like if we send data that the endpoint is not capable of processing, for example, we send too few columns, or we send the wrong value for the island, for example, this endpoint is not going to try to make a prediction. It's just going to return none. So we can handle that later. I'm printing out what the result was. I'm computing what the content type is going to be. In this case, I'm saying, okay, so the content type is going to be JSON. If context is none, meaning if we're running locally, I'm always going to return JSON. If we're running there, I'm just going to return the same accept header that the client specified. And I'm going to be jumping or dumping, not jumping. I'm going to be dumping the result in as the response and pass also the content type. That's it. That's the process output function. One thing that I want you to notice is how this implementation, the one that I created here, does not support processing batches of elements. If we pass a batch of samples here, multiple penguins, this implementation is not going to support it. The reason you can realize that that's happening is notice how the result is just a single element. And I'm assuming prediction is a single value here because I'm only getting a prediction for the first element. If you pass a batch of samples, you're only going to get a prediction back for one. There is one assignment for you to fix that. You're going to have to deal with this code and make it support multiple batches, the same way we did before. But I just wanted to just point that out. After creating the script, this is the whole script. Now we need to create our model with that script, tell SageMaker, hey, you're gonna be using a custom inference script. And then we need to register the model, and that's it, run the pipeline. That's pretty much it. So we've done everything else before. Here is unit tests for this model. You can take a look, there are a few unit tests there. So when you run them, see how many I have 4 unit tests. You can just check them out to understand better the code. Here, we need to create that model. So at the time, before we created the model, it was simple. We just specified that we wanted a TensorFlow model. Here, when we specify that we want that model, we need to also tell SageMaker, you need an inference script. And the explanation here goes into what SageMaker is going to do when we tell SageMaker, this model has a custom inference script. What's gonna happen is that SageMaker will trigger what's called a repack step. So in our pipeline, we will see a step that we did not create. That step is something that SageMaker will create automatically to repack the model. Remember, our model, we created it during the testing step. That model is just a package, a tart.gc package. But now we are specifying that we want a custom inference script. So somehow SageMaker has to uncompress that package, put the inference script inside, and recompress that package. That is what a repack step looks like. So here I'm gonna show you at the end, when everything is done, this is what that model.targc file will contain. There's gonna be a model folder, which is going to have the model version number, which we fixed to 001. Then we're gonna have assets, variables, and the saved model inside. That is the way we're saving the data, the TensorFlow saved model format. We're also gonna have a features.joblib and a target.joblib because we added those to the model.targc file. And then SageMaker is gonna add an extra code folder. And that code folder will contain the inference.py script and will contain a requirements.txt file if we add one. And I think we will. Yes, we will add one. That will be created automatically by SageMaker during that repack step. When I show you the pipeline, you will see that repack step. Why do we need to create a requirements.txt file? I just want to make sure that within this container that we're gonna be running our model in, we have access to NumPy, we have access to Pandas, and we have access to scikit-learn, the proper version. So I'm creating this requirements.txt file. I'm saving that file in the same location where my inference.py script is. And now I'm going to specify, I'm gonna create my TensorFlow model. Remember, this is a class that we used before to define our model. The only difference is that now we are specifying a custom entry point. So let's see, the name is gonna be Penguins, that's the name of the model. The model data, where is the data coming from? I'm just pointing to the train model step, the S3 model artifacts. So we are creating a dependency between this model and the train step. Whatever the train step outputs as the model, that is gonna be the model that we're gonna be passing here. The entry point is inference.py. That's the file that we created. And the source directory is the pipeline directory where we saved that inference file. By doing this, we are telling SageMaker, you will need to create a repack step, okay? Because you have to take that targc file and add the code that we just created inside. Then I specify the framework version, which is gonna be 2.12 for TensorFlow, the SageMaker session, and the role. This is our custom TensorFlow model. Now we need to register it. To register that model, I'm gonna register this in a different model group. So we have like 4 model groups up to this point. The basic penguins, the pipeline penguins, we have the custom penguins, and we have another one, which is the pending penguins, which is the one that we used for deploying the model using EventBridge. So I'm gonna be creating this model package group. I'm gonna be calling the create registration step to register this custom TensorFlow model. Notice that here, I'm specifying that we only support application JSON. We do not support anything else. I'm passing the metrics. That's pretty much it. I'm gonna modify the deployment step. So it uses this registration step to gather the model from, or the model package ARN from. and I'm modifying the condition step so I can pass the new register model, the new deploy step, and that's it. And I create a pipeline. Our pipeline here looks pretty similar to everything else that we've done before. There are no changes here, same parameters, same steps here, pre-processing, train, evaluate, and the condition step, and that's it. When I run this pipeline, let's see what it looks like here. Let's go to pipelines. I run this off camera, and here is the execution. Let's see what it looks like. Okay, so we have a regular pre-process, train, evaluate. None of that is new. We have our condition step, check model accuracy. If it works, it goes to a repack model. See, this step, we did not create that step manually. That is a step that automatically SageMaker adds to our pipeline. And remember, what SageMaker is gonna do in that step is grab our model that comes from the training step. It's gonna grab that model, it's gonna uncompress it, add the custom code inside, recompress that model, and re-upload that model. And then it comes the register model step, and then finally a deploy step that will automatically deploy this model. Because I ran this before, we should have an endpoint running. This is the endpoint. It's in service, so we can test it. Let's see how I tested it. It's the same code that we used before. So I'm having here a deserializer and a serializer. So I'm gonna be waiting for the endpoint. Remember, this is a waiter. It's gonna make sure the endpoint is in service before it lets you go through. It goes to the next line. I'm gonna be creating a predictor, and I'm specifying, hey, the data that I'm gonna be passing is gonna be in JSON. So use that as a serializer. And the data that I'm gonna be getting back is gonna be in JSON. Just use a deserializer in JSON. And then I call predict. And when I call predict, I can pass a JSON object with raw data, the island. It's gonna be dream and the Coleman length and all of that data in raw. I don't need to do the transformation before calling this endpoint because that is happening internally. And then finally, I print out that response. If I execute this line, here you have it. I'm gonna get the prediction is idly and the confidence is 0.62. Now, of course, this endpoint does not support CSV. I did not write the code to support CSV. And this endpoint is not going to support multiple items. So I cannot pass a batch of items because I'm not gonna get predictions for each one of them. Those two are assignments for you. This is a different way of supporting or adding the ability to this endpoint to support custom transformations internally instead of letting clients worry about that. You can do that internally. This is a much better way, in my opinion, because it's simpler to implement than the inference pipeline. The inference pipeline is still very, very helpful when you have a much more complex approach and when you want to keep those components separate. But this one is much better if you just want to keep things simple, just to transform input and transform output. Hopefully this helped, and I will see you in the next one.